welcome to this first lesson on lighting with cycles in Blender 4.2. In this quick introduction, we'll go over how Cycles works and calculates light. Blender Cycles render engine is a so-called physically based path tracer, meaning it simulates how light behaves in the real world. However complex this sounds, the great thing is that it's all done automatically for you. So you don't have to understand all the technicalities behind how this works. However, it's useful and important to understand how Cycles calculates light so you get a better grasp of lighting with Cycles and thus all the tools explained in this chapter. So let's break down the steps involved in this complex yet amazing process. First of all, Cycles starts with light sources in your scene. These could be point lights, spotlights, area lights, or even emissive materials or HDRIs. Each light emits rays in various directions. Then, when a light ray hits a surface, Cycles calculates the interaction based on the material properties. It determines whether the light is absorbed, reflected, or refracted. Reflective materials will bounce the light rays off in specific directions, while refractive materials like glass will bend the light as it passes through. Materials with a high roughness, like for example this one, scatter the light rays drastically, resulting in a non-reflective surface finish, or also called light absorption. While you're rendering, either in the viewport or your final render, Cycles follows all of these rays as they bounce around your scene, interacting with multiple surfaces. And this is the process that's called path tracing. Eventually, some of these rays will hit the camera, which in turn contributes to the final image. When your render begins, the render may look very noisy because only a few rays have been traced. Cycles uses a technique called sampling where it traces many rays over multiple passes to reduce noise and achieve a clean, realistic image. The higher your sample count, the more light rays are fired, traced, and received by the camera, resulting in a cleaner and more accurate image. However, higher samples also mean longer render times since all these additional rays have to be calculated, and thus it's important to find a good balance between quality and speed. You can control the number of samples and very many other additional render settings in Blender's Render Settings tab to optimize your workflow and get the best results for your project. And there you have it, a quick overview of how Cycles calculates light inside of Blender. And with this knowledge, you can better understand and manipulate lighting to create stunning photorealistic renders. Now let's get into some of the amazing features that Cycles lighting has to offer.